Welcome my dear students. Today we are going to discuss a new topic which is force on dielectrics. What are the different forces which act on the dielectric is the main topic of today's class. A dielectric also is attracted into an electric field. During the last module നമ്മൾ കണ്ടക്ടറിന്റെ ഡിഫറെന്റ് പ്രോപ്പർട്ടീസ് ഡിസ്കസ് ചെയ്തായിരുന്നു. അവിടെ we were discussed on the force acting on a conductor that is related to some electrostatic pressure and something like that. Similarly, in the case of dielectric also, a dielectric is also attracted into an electric field. In a dielectric material, the bound charge tend to accumulate near the free charge of opposite sign. Hence a dipole are created. These dipoles are attracted by the field. Consider a slab of linear dielectric material partially inserted in between the plate of a parallel plate capacitor. From the figure, we can see that the white color of the plate is representing two parallel plate capacitor and a gray color is for a dielectric slab. A dielectric slab is partially inserted in between the capacitor plate. Till now we have considered the electric field of the parallel plate capacitor is uniform inside and zero outside. Just like we can see a representation of a parallel plate capacitor, the left side is indicating the plus and the right side is indicating the minus sign. So, electric field will start from a positive side and end in a negative side. From the figure, it is clear that inside a capacitor, the electric field is uniform. This is the general case which we were discussed throughout till now. But there is a change on this concept. If this were literally true, there would be no net force on the dielectric slab since the electric field everywhere would be perpendicular to the plate. അപ്പോൾ കപ്പാസിറ്ററിന്റെ പ്ലേറ്റിനിടയ്ക്കുള്ള ഇലക്ട്രിക് ഫീൽഡ് യൂണിഫോം ആയിരുന്നെങ്കിൽ there would be no net force acting on the dielectric. ഡയലക്ട്രിക്കിന്റെ മുകളിൽ ഒരു ഫോഴ്സും അപ്ലൈ ചെയ്യുമായിരുന്നില്ല. കാരണം ഡയലക്ട്രിക്കും ഇതും തമ്മിൽ ആംഗിൾ 90 ആയിരിക്കും. സോ എഫ് ഡോട്ട് dxന്റെ ആംഗിൾ വെച്ച് നോക്കുമ്പോൾ അവിടെ നെറ്റ് ഫോഴ്സ് എന്തായിരിക്കും? 0 ആയിരിക്കും. സോ up to date we were discussed that there is the uniform electric field inside a capacitor. But here in reality the field near the edge of the capacitor is not uniform. ഈ capacitor പ്ലേറ്റിന്റെ എഡ്ജിലുള്ള ഇലക്ട്രിക് ഫീൽഡ് യൂണിഫോം ആയിരിക്കില്ല. There is a fringing field around the edge of the capacitor. This non-uniform fringing field is responsible for the force on the dielectric slab. Here we can see the original real picture of a capacitor plate where black line represent a positive capacitor plate. Similarly, in the below region there is a negative capacitor plate. In between them, most of the electric fields are uniform inside the material. However, if you are going to the edge of the plate, there is some non-uniform electric fields. This non-uniform electric fields on the edge of the capacitor plate is responsible for the force on the dielectric, and this non-uniform electric field is known as fringing field. So, there would be a force of attraction on the dielectric plate. So, we will go to discuss that. It is very difficult to calculate the fringing field directly. So, we will go to an indirect method. By using an indirect method, we will find what will be the force and hence what is the work on this fringing field. Let W be the instantaneous energy of the dielectric slab which depend upon the amount of overlap. Let the slab is slightly pulled out through a distance dx by an applied force Fa which is equal and opposite of the electrostatic force on the slab. Consider a dielectric slab which is partially inserted in between a capacitor plate. The capacitor plate have a B, this side have a distance B and this side have a distance L. Now we are applying a force on dielectric slab so that we can pull this dielectric slab to a distance x. So in this way, the dielectric slab is partially inserted in between the capacitor plate where x have some free air and L minus x have a dielectric slab. So while we are pulling this dielectric slab, we have to apply some force. Similarly, we have to apply some work on the dielectric against the electrostatic force. So we will work on the electrostatic force. So the work done is equal to dW, which is equal to Fa into dx, and Fa is equal to dW by dx. This electrostatic force Fe is equal to minus of this Fa. Fa is the applied force which we were applied. So this applied force equal and opposite to the electrostatic force. So we will mainly concentrate on the electrostatic force. So this is minus dW by dx. Energy stored in the capacitor, that is we were already discussed, that is capital W is equal to half CV square. We can substitute and we will get Q square by 2C. Now, what is C? C is the instantaneous capacitance of the capacitor and is given by C is equal to epsilon 0 Bx by A plus epsilon B into L minus X by A. എന്താണ് ഈ equation? The first term representing the free gap capacitance due to this free gap, because the dielectric slab is partially inserted, so there would be some free air in between the capacitor plate. So the equation for a capacitance of a capacitor C is equal to epsilon 0 A by D, where A is the area and D is here is A. So area is B into X. Similarly, the next second term for the capacitance of the capacitor due to this dielectric slab. So permittivity of the material, that is epsilon B into L minus X is the area distance covered by the dielectric. So in this way we can find two terms which is equal to epsilon 0 Bx by A plus epsilon 0 into 1 plus chi E into B into L minus X divided by A. What is that? Epsilon can be changed into epsilon 0 into epsilon r, where epsilon r is the relative permittivity, which is 1 plus chi E. Now just expand this equation and we can find epsilon 0 B by A can be taken as a constant from outside. The first term will be remaining with X plus 1 plus chi E into L minus 1 plus chi E into X. So this term can be expanded. Now which is equal to epsilon 0 B by A into X plus, we can just substitute this is epsilon R. So epsilon R into L minus X into chi E. We can cancel this both X. So the remaining time will be epsilon 0 B by A into epsilon R L minus chi E into X. We can just take a differentiation because we can change this X from 0 to something. So X is a variable according to, so by using dC by dx, which is equal to epsilon 0 B by A is a constant. The minus can be here. So d by dx, that is 1. So final equation will be minus epsilon 0 B chi E divided by A. We assume that the total charge on the capacitor plate is held constant as Q. W is equal to Q square by 2C from the previous equation. We can differentiate with respect to C and keeping Q is a constant. So dW by dC is equal to minus Q square by 2C square by using the intermediate step. Finally, Fe is equal to minus dW by dx, which we can be expanded as like this, minus dW by dC into dC by dx. We can have both dW by dC and dC by dx. So we can substitute both these equations from the previous one. So we will get minus Q square by 2C square epsilon 0 B chi E by A. Here we have 3 minus term. One is here, one is from dW by dC and another one is from dC by dx. So final equation will be minus epsilon 0 b chi e by 2a into v square. The negative sign indicates that the force is opposite to x. In this way, we can find the force on the dielectric by an indirect method due to the complexity of fringing field. Fringing field is the field in between the capacitor plate on the edge. In this way, the electric field is attracted on dielectric so that the dielectric slab is pulled into the capacitor by the field. So this is the force experienced by the dielectric slab while we are placing in between the capacitor plate. Thank you.